Start up again. So, oops, that's not listening to me correctly. All right. So leads. Leads are actionable things. You know, leads for an investigation, a standard term for any kind of investigation, but in particular in incident response, leads are actionable things. Things that we can measure quickly. Network traffic, identities of suspects, subjects we can measure. So we need things that are relevant to the investigation, things that are actionable, and enough detail that we can tell a compromised machine from a non-compromised machine. And then we have to verify this information. You have to look at the data and investigate how useful it's going to be. For example, a network intrusion detection system like Snort will generate alerts when it sees suspicious traffic, but the problem is it will often make a mistake and warn you about something that's really not a problem. So when you do have a warning then you have to investigate it. You want to see what the local machine that was involved is. If you're using network address translation, which almost everybody is, then it will be a little bit of a chore to find out exactly which machine was there, but you should have NAT logs for that reason. Then look at the raw packets, look at other connections from that host, and try to figure out whether this is a real event or a false positive or just something irrelevant, not related to your investigation. And that's called veracity and context. Is this really true? And in context, is it really useful? So humans and automatic systems both tend to misinterpret traffic in different ways, and you have to know that. One fun fact about almost all security devices and software is it almost always is riddled with false positives, because if you pay a bunch of money for something and turn it on and then nothing happens, the customer is not happy. So they sell it with the sensitivity turned up high enough that it will start alerting you right away, which is not necessarily a good thing, but that's the way it is. So once you're trying to turn leads into viable indicators, and the indicators now can hopefully detect the ongoing events and help you find future attacks. Yeah?
Are these IOCs indicators?
Yeah, those indicators are compromised, exactly. So you want to find suspicious conditions that will lead you beyond the leads you have to more leads. You can go around in a little circle. So you're trying to turn leads into indicators. Now the nicest thing is property-based indicators, where you have nice, clear observables, like a file with an MD5 hash or a registry key, or a unique name mutex in the malware analysis class, which we do have here. Mutexes are covered in many other things. Mutexes are, if you have a program running in Windows, it has handles. Like every time you open a file, you'll have a handle to the file. When you read or write that file, you refer to the handle in your code. There are special things like handles called mutexes, which are named quantities that are visible to other processes on the machine. And this is, normally each process has its own memory space and it can't talk to any other process, but it can send a signal through a mutex, which is called a mutant also. And malware typically uses them because when you get infected, one of the things the malware wants to do is to check if it's already infected this box. It doesn't want to try to infect it again, because that'll just lead to an endless cycle and make too much processes and cause it to crash or something. So it usually is a mutant typically, as the existence of a certain mutant warns the malware that I've already taken over this box, don't try to take it over again. So that's something you could look for. The other kind of leads are the anomaly-based or methodology-based. These are fuzzier. These are things that aren't as clear as the existence of a file with a certain hash. Other indicators like unexpected executables in a Windows directory where you shouldn't be anything except what Windows put there. And then you have a life cycle, and this is very much like the life cycle of a hard disk type forensic investigation, which I took a lot of courses in and have taught about for years. You have some data from the original statement of the case. There's some reason they called in an IR team, so you have some facts. So you use those facts and create some indicators of compromise and verify that they're relevant, verify that they work, and then measure something, and from that you get more clues, and you make more indicators, and you create more indicators, and you know you're done when you're not finding anything new. I mentioned before, this is a common thing you do in really difficult problems, like really difficult quantum mechanics and physics problems. You can't really solve them, so what you do is you make an approximate solution, and you refine it, and when it stops changing, you say, I'm done. I've either found the right answer, or at least I've gone as far as this technique can get me. Yeah?
Do you know it's convergence as well?
Yeah, that's called convergence. They often call this a convergent solution because it's not a real solution in the sense you've really proven this is the answer, but it is the best you can do with the tools, and often that's good enough, and sometimes it isn't. And that's just what you have to settle for in things like this, where it's not math that's been solved, it's a real-world problem that you're trying to solve, and you may not be able to get a perfect solution. So your host-based indicators would be, what you're hoping is to get a simple binary answer. Is it infected in part of the investigation, or is it not? So you want a list of things you can observe, and the malware samples he uses in the examples come from this book. That's why I taught this class, because of this book. This is a great book, as well as a very good cover picture. And the point of this book comes with a whole bunch of fake malware, which you can use to learn how malware works with. Because if you take SANS courses, they give you live malware to work with. But I can't do that in this environment at a public college where I'm handing out students, people are downloading it and doing it homework on labs and at home and at work and all sorts of places. So I wouldn't teach this class until we had a nice book full of fake viruses. So these things are harmless, and therefore you can practice in an environment like this that is fairly uncontrolled. So it's very nice. And that class comes around every few semesters. It'll probably be another year or year and a half before it comes around again, but it's a fun thing to do. It turns out almost everything about malware analysis is Windows internals. What you're really learning is all the 100 ways to make Microsoft software do strange things, because that's what the bad guys have done. That's how all the malware does, is find some backwards, unexpected way to do things so you can't detect it with the usual tools. Yeah?
Is that why OS X is more well architected? It's based on Darwin or...
There was a belief until about 2 years ago that Linux was more secure than Windows. And then Heartbleed happened, and all those people have pretty much shut up and crawled back under a rock. And Apple, and for the last couple of years, I think the old-fashioned capitalist argument has been coming to the fore, that if you pay money for your software, you actually get a better product. But anyway, no, I don't think OS X is built better than Windows. OS X is just a smaller target. I think that's been proven. It's just not as popular. So if you're going to spend $1,000 writing malware, you might as well attack Windows and get more money. And that because Android came out, and Android made itself into a big target, and they made it in the crappiest OS you could possibly make it by making it so no one can put on updates. And that it's full of viruses, a million viruses. So Linux is not any safer than Windows. It's just what Microsoft always said. The only reason they have all this stuff is because they're popular and everyone's shooting at them. And if you were popular, you'd have all the same problems, and Google proved that that's true. Anyway, so a file MD5 hash might look like this. This is just sort of pseudocode to show how it is. So you'd say, hash the files. If you find this hash, then raise an alert. So this means every time you test it, you're going to have to calculate the hash of every file on that machine, which is not terribly expensive, but that's a good amount of processing cycles. And this is what Tripwire does. Hashes the files and sees if the hash changes. And when you run Tripwire on a server, it will push the server to like 100% CPU for maybe half a minute. So you can't afford to do it every minute. Most people do it once a day or once an hour or something. For that reason, yeah.
I know you can do this on a Mac,
yeah.
MD5, but how do you do the SHA on a Mac?
It's the OpenSSL SHA one.
Okay.
If you have OpenSSL and SHA, you can do them all.
Okay.
And I think there might be a SHA one some too, but OpenSSL is the best because then you have got SHA 2. If you want to be a mathematical purist, we shouldn't be using MD5 or SHA 1 anymore. We should all be using SHA 2. But in practice, MD5 is faster and usually good enough. And certainly for things like this, everything is a fast pass. So even the fact that it's faster to calculate might be good enough to make it useful. Anyway, now Windows files that run are portable executable files. They all use a format called the Windows PE format, which we go through in great detail in the malware analysis class. But the main thing here is to know all the things, executables, coms, and dills, all use this. Microsoft uses dynamic libraries, which is enormously important in the world of malware and attacking machines because it makes it very easy to attack machines. It is done to make their programs run faster and use less memory. But many programs will share the same library. So in the header of the PE file, it will say which libraries I depend on. And it'll have to make sure that all those libraries are loaded in RAM before it can run. But real programmers that write in reasonable languages like Visual Basic end up only importing certain libraries and certain common combinations, because they write code in a high-level language and there are certain libraries used together. Malware authors deliberately do strange things that are not what you would get from any normal programming language, and you can spot patterns of their inputs to show that this is probably malware because it's loading strange libraries that no one would really load together at the same time. So here's an example. You could look at the PE header and get the compile date of the malware, and you get the file size. So here's another way to do it. You could see if there's a file that was compiled at this particular time. That would be a clue. Now, of course, if the malware is modified in any way and recompiled, that date will change, and so will the hash. So both of these are not great indicators of compromise. They'll only work for a brief period of time until the next version of whatever it is comes out, and then they won't work anymore. So another thing you might want to do is something less specific, like this. You have the MD5 hash, or it's going to the command and control center, which for this fake malware is practicalmalwareanalysis.com. So if any in the DNS cache, which are recently resolved domain records, there is that domain name. That means this machine has been sending traffic to that domain, and there's no reason for anyone to do that unless they're infected, because that's a malware domain. That's the idea. And then if there's a service running called Internet Network Awareness and so on, or the file name is like this or the header is like that, that's a more thorough indicator of compromise that will probably continue to work even when later versions of the file come out. But the problem with that is that's going to be kind of slow to run, making all those checks, or it has to do all those calculations. So you have to decide how complicated to make your rule, and what you're trying to do is hit the sweet spot where it's fast enough that it doesn't slow down the system enough, but it's accurate enough that it finds the malware without too many false positives. And that's the game here. Snort in particular is famous for this. You can write Snort uses like regular expressions. You can write a complicated rule that looks for a complicated pattern, and what will happen is it will slow down so much it'll miss most of the traffic, because the engine has to process a lot before it's ready to process the next packet. And that's an issue. So getting too clever can hurt you.
It just drops those packets?
It drops packets when it gets too busy. That's true of almost all sniffers. It's a big issue. You don't really get all the packets. So the import table is the part of the portable executable header that says what libraries it's using, and there may be unusual patterns of libraries. Like here's somebody who creates a service, creates a registry key, reads a file, and opens the internet and creates a process. And that's an unusual amount of combination of things to have at the same time. Also, if you go into the other class, we talk about it more, there are high-level libraries and low-level libraries. Usually only real programmers only use the high-level libraries that make it easy to do things like internet download file, and the low-level libraries like open socket, send to get, do this. That's kind of nuts. Nobody but a malware person would usually do it that way. They would use the higher-level function that does it all in one go. Anyway, all right, so there are other kinds of IOC. You might look for things that the bad guys do, and this is a really old attack that's been used to take over Windows machines since Windows NT. Microsoft, in order to serve everybody and probably to pass federal laws, of course supports handicapped people trying to log in. So you might have no ability to type on a keyboard and you have some kind of other device you're using because you have a handicap, and they want to be able to log in. So there's a special keystroke to make that happen, and in Microsoft you press Shift key 5 times and it will pop up, give you an opportunity to pop up alternative things like the on-screen keyboard. And so, what's that?
Is this the same as sticky keys?
Yeah, well, sticky keys is one of the options. It'll offer. Sticky keys is one thing, so that if you're shaky, it will only get one press, and there's a bunch of options for handicap accessibility. But since this is almost never used, it's a common target for attackers. And if you can just replace the file, this whole thing is done by this one file, Seth.exe. So if you replace that file with another file, remember this has to launch before you log in. So anything that launches as system with full privileges over the machine. So if you can replace that file with another file, then you trigger the handicapped accessibility, then it launches whatever you put in as system. And all you have to do is put cmd.exe there, and you'll get a command prompt with system privileges before you've logged in. You totally own the box. This is an old trick. It's been around forever. Called a companion Trojan if you put it in another directory. If you overwrite the original file, it's this overriding attack. It's quite effective. And if this is the technique being used by the bad guys, then you can find it by looking to see if the Seth.exe has been replaced. And that title should be Seth.exe, which may be Apple trying to misspell my words. Apple seems to have some problem with the words I use. Anyway, all right, so you want to know what happened there. So direct file replacement, you could just look at the MD5 hash of that file and see if it's the MD5 of cmd.exe, and if it is, that means we're going to raise an alert. The problem is there are multiple versions of cmd.exe. Microsoft keeps modifying it for different versions of Windows, so there's not just one MD5 hash. Yeah?
Could this Trojan be used to deploy a keystroke logger or something?
Well, you certainly could do it directly. One thing about this one, which makes me think this is kind of an artificial example, is I don't think you can trigger this with network traffic. You have to actually physically touch the Shift key, so this is not something that you could really do from over the internet, but an inside attacker could do it, I guess. And anyway, so you could start listing multiple hashes and multiple creation times, but that's kind of for the birds, so what's better is to find a more clever way to do it. And what he found was cmd.exe is bigger than Seth.exe. So all you really need to do is see if the Seth.exe is bigger than it should be, and that's a much simpler test and is much more likely to continue working as various versions of things come out. So all he does is if the file size is bigger than it should be, then that raise an alert because that shouldn't happen. So that's the game. Snort signatures are similar. A lot of things like this. This is how you find efficient signatures, and if you're not careful with this, you end up wasting a lot of time and not quickly finding the bad guys. Yeah?
Is this a Snort signature?
No, this is written in just sort of general language.
Okay.
But we'll see it in a formal language in a minute here. So here's another one that looks for a debugger key. There's an option that hijacks the debugger to go to CMD. So somehow you trigger an error, and then when it launches the debugger, it gives you a command prompt. That's the thing that used to lead to Dr. Watson in the old days of Windows, and now it leads to other things like WinDebug. So there's a registry key that you can check for, and if that key contains Seth.exe, which it shouldn't, then somebody has inserted a debugging key into Seth.exe. And there's the official format, the Open IOC format, which is the one Mandia invented, which has not yet been accepted as a general standard. This is how they would write these things like Snort Signatures that have these things. It looks like an XML-based format, and they have or and then full path contains this. By the way, it's a good idea, instead of making the path C Windows system, to say path contains Windows system, because it might not be C, it might be G or E. So that's one solution for that, is to give part of the path. The Microsoft solution would be to use their environment variables like %system%, which goes to C Windows system and so on. But anyway, there's it's an issue when you're writing things to consider the different systems it might be on. And so then your network-based indicators. You're trying to find something that will rapidly tell you whether a session is relevant. Now you can just look for a set of bytes present in the first few bytes of a session in the packet, but if you do that, the signatures might require editing. DNS monitoring is usually fast and efficient, very nice, much nicer than trying to look for a certain pattern of bytes, just look for certain domain names. As a matter of fact, there was a fun article I saw about 3 weeks ago from a guy who used, I think, PowerShell or Visual Basic to write scripts to look for the entropy of things. Like, if you have just random letters, the entropy of that thing is 8. It's maximally, for a simple way to think of it is you can't zip it. If you zip it, it won't get any smaller because there's no pattern. But human languages have patterns in them. They're not random at all. English words are not random. If it turns out English words only have an entropy of 5 or 6 bits per byte, and random bytes have 8 bits per byte. So you can just run this mathematical test and very quickly detect things that were made by machines and not humans. You can detect malware domain names and password brute force attacks and stuff. So it's pretty cool, actually. And here's another example of that, looking what's coming in a DNS. So a DNS query saying, where is practicalmalwareanalysis.com comes in. If you look at how that's going to look, you might be tempted to look for this string, practicalmalwareanalysis.com. And if you write a rule that looks for that string, it will not find it because that is not how it's sent. If you look at the Bible, which is the request for comments that determine everything on the internet, it tells you how this works. The way it works is you have a query name here, and the QNAME field contains the parts of the domain name split into labels, and each name is preceded by the links. You have 18 bytes of this, then you have 3 bytes of that, and there's no dot. The dot is not sent to the network. You have fields. hills.ccsf.edu is just sent as 3 separate fields. So what you're really looking for is practical malware analysis 3 That's the actual string you're going to find. And you can see it in Wireshark. Here's the Wireshark query resolving it. And you can see up here, it says practicalmalwareanalysis.com, but if you look down here in the bytes, it looks like practicalmalwareanalysis.com, but this is really a binary 3. And the way this works is anything that's a non-printable character, it puts a dot there. That's not a period, which is, I think, something like 3D or 5D. So if you want to write a Snort signature for that, then here's how you do it. You'd have a message, which will tell you if it comes out, and there's the content. 18, followed by practical malware analysis, followed by 3, followed by com, followed by 0. That's the actual bytes that make it up, and that's what you need to look for. Anyway, all right, I got a few more iClickers, and whole section after this. All right. All right, so Tripwire sends an alert, but it's a false positive. So what's wrong with that alert? I'll quit at 30. All right, what they say about that is it lacks veracity. It's not true that you are under attack because that alert went off. It's lying.
What was the other word that you used on that slide? Veracity and context. Is it context?
Yeah, context was the other one, which we'll get to, yeah. All right. So every program and every service on Windows is what? All right, looks like I can quit at 25. Looks like the answer is pretty much in. All right, they are portable executable files, PE files. Okay, good. Also the libraries, the DILs. All right. What network protocol gives you the easiest and fastest indication of malicious activity? All right. Guess I'll quit at 25. All right, and that's DNS. DNS monitoring is real popular these days. Snort is not a network protocol. Snort is the device you might use to do it. But DNS monitoring is highly recommended these days as giving you a lot of bang for your buck. Quickly finds out information without burying you under megabytes of junk you have to hunt through. I had a student come to me and say somebody at work is doing whatever's forbidden, like games or porn. How do I catch them? And I said, just turn on Wireshark, look at the DNS. Came back next week and said, that totally works. We know right who did it. We know when they did it. You don't have to do anything complicated or confusing. It's just sitting right there. This clown going to the forbidden website right from his address. All right. So what's part of the PE header? All right. Quit at 25. All right, and that's the import table. The MD5 is not in the header. That's just a property of any file. You can calculate an MD5 by just combining all the bytes with a mathematical algorithm. But the import header is part of the specification of a PE file that specifies what libraries it's going to use.
Same thing.
What's that?
Include statement in C, right?
It's like the include statement in C, yeah. So I think, by the way, it occurred to me I should mention, in case people feel like they're doing badly on the quizzes and need some points, there's extra credit projects, and you also get extra credit by going to talks, like this one at Kashmir Hill, or we're going to off-campus training events, like conventions or meetups or something. So, you know.
Are meetups included?
What's that?
Meetups
Sure, meetups are fine. I highly encourage you to get out there, meet people, give a talk, go to a con. You want people to know about you, then they'll remember you when it comes time to make a startup and hire people or something. You can't be hiding it. The world is only social networking now. You got to do it. All right, so dynamic analysis. This is what you yeah. Go ahead.
I have a question about DNS monitoring.
Yeah.
So it's a .com domain. That's why it's 3 bytes. There's a 3 in front of it.
No, the 3 is in front of it because it's 3 letters. That's just the number of letters.
So you say .us, it's going to be 2.
.us would be 2, exactly. Yeah, and now there's .info would be 4, and so on. Yeah. Good. All right, so this is what you do. Like I mentioned, this is the standard way you analyze malware, and now there's a lot of places that will do this automatically for you. But here's how one form of dynamic analysis. Basically, you run it in a virtual machine and let it get infected. If you want to be polite about it, what he did was make a fake DNS server here that will redirect all traffic from every domain to just a general server that will answer queries. So you don't even contact their server. Now, sloppy companies, like I was at a training event from the European company that does this, an organization, HoneyNet. HoneyNet Alliance came and taught here in San Jose. And the Europeans did it this way. They would put up sandboxes where the entire suspicious machine is isolated from the internet, and there's a fake internet, so it thinks it's calling people, so no traffic actually leaves your enclosure. Then you run a virus. And the people there from like American companies like Symantec said, nah, we just infect a machine, let it phone home, well, who cares if it's another bot for a few minutes? They said, but you're going to be on a blacklist, you're going to be harboring malware, you'll be on a list of companies. Yeah, sure, so what? Who cares? I'm trying to get the job done here. And this is the American way, fast and sloppy, the cheapest way to get to the answer, but they were horrified. You could do it in a more precise way, but anyway, these are the options. These guys do it the precise way, where they don't actually let the malware talk to anybody, but they send it talk to a fake internet that will give it the feeling it's talking to somebody, so you see what kind of network traffic comes out. Then you just run it, see the network, and you see what it does. It sends out a GET request to serve.html in the practicalmalwareanalysis.com domain. And those are now indicators of compromise. You can look for that traffic, and people that give you that traffic are presumably being infected by this thing or already infected by this thing. So then, once you have an idea for your indicators of compromise, test your rules. I'm pretty sure that should be IOC. All right. And so run a representative sample of machines, and what you want to, there are two issues here: whether the data is relevant to the indicator and whether it's common to the environment. And those are basically false negatives and false positives. That's the issue here. So consider this attack life cycle. Email comes in with a payload, somebody clicks on the link or the attachment, that runs a dropper, which is supposed to be a Word document, but it's actually an executable. So the executable opens a real Word document, so the viewer sees something, and then it secretly downloads a second stage program that installs some kind of malware like a rootkit in the background. This is a very common way it happens. And so there are various ways you could detect this. Now, the less effective indicator, which is what an automatic network scanner would do, the automatic network scanner would just look at the file passing through, and they would just detect the first file, which is the dropper, and not the second file, most likely. So they'll list on the MD5 hash or something of the first file and call it on a list. And this is what happens if you use Metasploit and make malware and run it against antivirus products. I did that a couple of years at DEF CON, and I'm trying to find out how much do you have to modify these things to get through antivirus, and almost all the malware just identified the compressor on the outside of Metasploit files. They didn't even recognize what was inside there at all. It was the same kind of very superficial analysis. So that's one way to do it, but it's not really getting to the heart of the matter. A much more effective indicator would be to look for a file entry in the prefetch directory. If you want to do something on a computer and then lie about it, you're in deep, deep trouble, because Microsoft Windows is spying on everything you do. And it's not even because they want to spy on you, it's just to make it efficient. So there's a thing called the prefetch folder, which lists the last 127 programs that have been launched, when they were launched, and who launched them. It's awesome. And the purpose of this is, while you're not doing anything better, Microsoft preloads those programs in RAM, so in case you click on them again, it'll load faster. So they want to know what you seem to like. What is it you've been loading? But it does mean there's records here. So looking in the prefetch folder, we can see that some file has been opened, and that would be the malicious file. You can find the Word document, the innocent Word document that opens. That would be a clue. And you can, the retrieval of the second stage may be logged in, and your DNS cache will show that you've been resolving the forbidden domain names, and so on. These are all other things that might be more effective. Yeah?
So how about if we delete periodically the files in the prefetch folder?
Some people like to do that, deleting the prefetch folders, and I think it's harmless to do it, but it will just regenerate. By the way, it doesn't always work either. Sometimes when you go, it's just empty. A lot of these things don't actually work as advertised. But yeah, you could delete the prefetch folder, and I suppose you could, in principle, make some kind of automated job that constantly deletes it. And then what would happen is your machine would not run quite as fast, but it would be more private. There's another thing, you can also put on a product called steganography that will constantly scrub your hard drive to remove all the unused files completely, so there's no remnants left. And these are things you can do at the cost of lowering performance but increasing privacy. If you have an SSD, it is very likely that it's automatically scrubbing itself anyway. Yeah?
That's steganography?
Steganography is one of the programs that does that, yeah.
Hiding images.
Yeah, what's that?
The steganography was really
That's what it means, but the program is called steganography and does this, yeah. It also does everything, yeah,
Oh, I
yeah.
see.
I think there's a few of them. Anyway, so I might be wrong. I thought it was steganography. Anyways, then there's data common to the environment. This is false positives. Go run your indicator on some clean workstations and see if it goes off, because you might be detecting something that is confused with normal network traffic, and that's an issue. This was a big issue years ago when rootkit detectors first came out. They would give you, tell you 100 infections on a brand new machine. So that's really miserable. False positives are really a drag. All right, and then there's impact on environment. That's another issue. Remember that now it's entirely possible that the analysis from your scanner to detect these indicators of compromise is consuming a lot of CPU and hard disk time and network traffic now, so you might actually be slowing down and bringing down important work systems. So you got to test for that too. Run it on a few sample systems and see how big the load is and decide whether you can really run these indicators of compromise without messing up the company. All right, and then there's leads from humans, which is a big issue. When you are, I must say, okay, so you have to document what people say, and you have to allow them to tell you your story, and you have to avoid leading them, avoid pressuring them, avoid interrupting them, and don't criticize them. I say this is extremely important. I've worked a lot of cases where people have had trouble. I haven't been doing it as a professional making money, but people come to me with problems. I have several stalking cases, and the most important first step is to just go somewhere quiet and private and let them tell you the whole story. Because invariably, by the time someone comes to ask me for help, they have not only found the problem, they have struggled, and they have gone down a blind alley. And now what they're asking me for is not the real solution. Like, I want you to analyze every bit of my hard drive and save it and take it to court. And I say, well, let's hear the story. And when I hear the story, it turns out there's no chance of anybody going to court, and what you really need is something else. So it's really important to just let people tell you the whole story without criticizing them or pressuring them, so you find out what happened, and then you can help find out what we really need here, which is usually not what they asked for. Anyway, and you'll know, of course, when you have to involve other people, there may be other people involved, there may be other stakeholders.
I have a question.
Yeah.
So when you say before allowing the interview to opine, meaning before offering your opinion?
Yeah, and the interviewee should be, and
'Cause in the earlier one, you're letting them tell the story,
Yeah,
so that's all
yeah.
sorts of opinions.
yeah, you don't need to make what they're saying here, which I thought was hard to understand in the book too. Is you don't want to get them involved in justifying what they did. You don't want to be saying, you want to first just find out what really happened. This is something I greatly appreciated at my escrow agency. Problems happen, and I would go to the boss, and he would never get mad at you for telling him about a problem. He'd say, all right, I need to know what happened, and let's just plan how to fix it. He wouldn't waste time yelling at you and saying you should have done it. He'd say, I always want you to tell me. You have to learn this. This is really important. I think it's probably important with kids too, right? First, you got to tell me what happened, whatever it is, and I won't get mad, because I'd really rather know than find out in a month when the cops come tell me. Yeah.
From your professional standpoint, so you would say it would probably not be wise to record the conversation either.
Oh, no, I certainly wouldn't, because that would make them nervous. I would certainly start with just a quiet, confidential, personal interview. Same thing an attorney does. When I called my attorney after they accused me of hacking a hospital, I spent 2 or 3 days trying to get out of it, and then I called my attorney, and he was the guy I needed here. I told him what happened, and he said, well, what exactly do you want? I said, that's actually a very intelligent question, because for the first 2 days I was afraid I would get fired, and then I realized I can't get fired. If you have tenure at a college, it's more like marriage. We're stuck with me, they're stuck with me, and I'm stuck with them. They can't fire me, but what I can do is I'm kind of hurting them if I'm famous for being a criminal and they have me on their staff, so I'd like to fix it so I'm not hurting the college. He said, well, that's the first step, figure out what you want. Now I'm going to figure out how to get you there, and that was helpful. Anyway, so and it's usually when people are upset, they're not very clear on what they want, and they're full of foolish ideas like I want to get even or something. Almost always getting even is a waste of your time. Much more effective if you figure out what you want and get it. Yeah.
I was editing a manual for a section of the police department once.
Yeah.
And one of the things that they said for this type of crime was, well, not this type of crime, but the one we had the manual on, was you just let everyone tell the full story as they want, and then at the very end, when they're all done exhausting the detail, then you go back and you say, tell me about this again.
Yeah.
Tell me about this again. And
Yeah.
especially with children, because they say children, if you start to get upset or anything, they think that they're hurting you or they're upsetting you, so they just stop telling you things. So
That's
they're
right.
like, you just gotta be really neutral and just let them say whatever they gotta say,
Yeah.
and then come back.
I remember this very much as a child, how you'd never tell your parents anything because they never understand. You have to hide everything from them, and now that I'm the parent, I certainly wouldn't want that to happen.
But it's not even so much that they wouldn't understand as much as like some of the littlest kids.
Yeah.
They think, oh, mommy's getting upset, I'm hurting mommy.
Yeah,
Let me
yeah.
just stop saying this.
Yeah. Anyway, so now if you have external things, which is very common, like you track them down to some like Yahoo account, now you want Yahoo to tell you who owns that account. Well, of course, if you're the cops or something, you can rate search warrants and stuff, but most people, private organizations don't have that ability, so they're probably not going to give you much unless they're in the habit of just being nice and it doesn't look very risky for them. But these days, more and more people wish to have a public perception of protecting your privacy. I don't think very many of them really care about that, but they care about appearing to do that. So you can file lawsuits like John Doe lawsuits where I'm suing someone but I don't know who it is yet, which is kind of nuts, but you can do that. And that gives you the right to subpoena people to get some evidence about who you're talking about. And you can use discovery mechanisms. And if you have the Digital Millennium Copyright Act, there are special abilities to suck data out of people. And of course, if you go to law enforcement and they start a criminal investigation, then they have the power to force people to hand over data to some extent, although as we saw with the FBI and Apple, even the law enforcement can't really suck data out of people as much as they wish they could. So you can file a subpoena, as will be your legal department doing this, and that can compel an organization to divulge information about a subscriber. And most reputable businesses will require this so they can tell their subscribers, we don't just hand over your data unless we're compelled to by a court order. So if you report it to law enforcement, then it goes out of your hands and you can't stop it anymore and you can't control it. And most companies don't like that at all. They would much rather just resolve it in-house. You're not required to go to law enforcement. You can just decide not to press charges about whatever's going on, which is what most companies do because they really don't want to throw someone in jail and have a scandal. They'd rather just find out who did a bad thing and fire them quietly and go on. But there are some things where you must involve law enforcement, and your counsel will know, and this is the book tiptoeing around the famous big issue of child pornography. This used to be the reason why I know people quit teaching forensic classes, because 10 years ago, every forensic class was nothing but child pornography, because that was the FBI's #1 focus at that time. So that was what it was all about. Now it's a small part of it. It is a big issue. If you are doing any kind of computer work and you come across child pornography, you have to immediately abandon whatever you were doing and give that stuff to the FBI. Don't even touch it anymore. Even looking at it as a crime, even possessing it as a crime. Certainly, concealing it or erasing it is a monstrous crime, and you don't want to go there. Whatever you're doing is over, and now you hand it to these guys and never touch it again. That's all you can do. It's radioactive stuff, and nobody else can touch it. So you have to be able to prove that as soon as you found it, you gave it to them. This is why one professional rule is if you're doing computer maintenance, you never look at the images. There are rumors that went around every now and then. People at Best Buy had a bunch of images they took off people's machines of them naked and stuff. And this is highly unprofessional and also highly risky. It's rude to look at other people's images, and you don't want to know. You just want to have so many megabytes of data you put on the new disk and give. That way you can service people without lifting up rocks when you really don't want to see what was under that rock. Anyway, so if you have foreign entities like ISPs in other countries or people hosting websites handing out malware in other countries, good luck. I mean, unless you're the feds, and even if you are the feds, you're going to have trouble getting cooperation from foreign countries. So, you can try writing polite letters, but the odds of actually getting anything in any reasonable amount of time from a foreign provider is very small, and that's why people exploit this like crazy. Just bounce your stuff off another country, and everyone will pretty much abandon all hope of tracking you down. So law enforcement has more powers. They're more likely to get responses to subpoena and court orders faster, and they're more likely to not notify the subscriber, which is a big issue of contention in the privacy advocates these days, but it certainly is true that a lot of them hand it over without telling anybody. And of course, what the law enforcement does is at no direct cost to you, although you will have to provide some documents and materials and stuff. So it's an issue. If you do decide to go to law enforcement, it will help a lot if you document things clearly, maintain a chain of custody of the evidence so it can be used in court, and give the clear and concise and simple explanation to law enforcement without a lot of technical details that they don't need, because they just want to know what law has been broken, what evidence have you got. There are some people that do this fantastically effectively, like Seagate. The Seagate security officer comes and gives talks here now and then, and Seagate has so many hard drives and so many people steal the hard drives that they have a special truck which has got 12 GPSs, 3 microphones, and 4 cameras. And when people are hijacking shipments of hard drives, which apparently happens a lot, they arrange for them to hijack that one. And they record everything, and then they call the cops and say, here's the tapes, here's where they are right now, here's where they unloaded it, here's the microphone, please go arrest these clowns. They just hand them everything, and they're all set to go. So, that's what you'd like to do. I know when I used to work for under contract to the Federal Trade Commission, we did internal audits of every case. Before they came to us, we would have an internal audit at the end saying exactly what data came in, what did we do with it, what money came in, what did we do with it, where is it all, write it all down. We put it in a folder, and they loved, every year they audit you, and they loved to audit us because it was so easy. Everything was just ready to go. They just had to make sure that stuff was accurate, whereas they say they go to other shops and they've just got boxes of junk everywhere, and nobody really knows how much of it there is, and that's not the way to be. So it's very handy to have your stuff in a row. Then you'll get cooperation from law enforcement a lot better. All right, there are organizations designed to help this information sharing. InfraGard, I've been there. Their reports are not too exciting, but it is a place where you can meet FBI agents and get their business card and talk to them, and then you have somebody that will take your phone calls. And there's a few others here: financial service information sharing, then defense industrial base sharing. This is a big problem in America. In Europe, there are good laws, so companies can share information about attacks and threats, and they do it a lot. In America, there are no such laws, despite repeated attempts to pass them. They can't get it through Congress. So right now, every company pretty much hides all their network security information as a secret, so any attacker can just attack one company, and then when they get caught, they can just go take the same attack and attack another company, and another company, and another company, because they can't talk to each other because they're afraid of the liability of leaking confidential information to the others. And many people are aware of this, but nobody can change the laws in America yet. So that's just the way it is. Anyway, got the last batch of iClickers. So, here's the one. Early rootkit detectors found hundreds of suspicious files on a clean machine. So what's that? I've been told they've gotten better these days. I must have done this like 6 or 7 years ago. I was disgusted. First rootkit detector came out, I said, this will be great. It was not great. That is data common to environment. You're looking at data and it turns out that that data is common, so you're not actually getting anything of any value running this indicator of compromise. It lies to you and tells you a bunch of things are compromised that aren't. All right. Which one lets you test malware without sending traffic back to its CNC server? All right. I'll quit at 25. All right, and they did it in this example with a custom DNS server. So you reroute the traffic somewhere else. In our practical malware analysis class, we do it with a product called INET SIM that does this, simulates the whole internet, pretends to be the internet. Yeah.
What was dropper again? Dropper was the initial.
A dropper is the first
right?
file
The first file
that you get that then runs and drops more files. Yeah. That's commonly the way malware works. All right. And which one is not a proper action to prepare for law enforcement involvement? Well, you know. All right. I'll quit at 25. All right, obviously, you can't be physically restraining people. Only the cops can do that. All right, so I'll see who got the most right. And let me stop my recorder, which is here. This is 121, Chapter 5.